Good afternoon. It is June 13th, about 4:30 in the afternoon. I've had a handful of people ask me, see the falcon? I've had some people ask me to do a complete system overview. I break apart all my different systems in various videos, but I don't have one that covers everything. So this is a solar array. We've got 12 100 watt 12 volt panels. It's a 24 volt system, but I use an MPPT solar controller, so I can the controller can take the higher voltages. And the reason you want to wire your panels at a higher voltage is because these panels, each 12 volt panel needs fairly direct light to create 12 volts. So when you wire them in series, it takes less direct light to achieve battery voltage, and you need to get your panels over battery voltage to charge. So I've got these four wired in a series to 48 volts, these four and these four, and then the three series are paralleled down the middle. I've got a wire going down that guy and into the ground, and that sends the power into the house, and that way I get power from dawn till dusk. If there's any light in the sky, if there's clouds over, it's got to be damn thick for me not to be making power, and that works fantastic. I end up harvesting a lot more power per day. I average about 6 kilowatt hours a day out of this, just the solar, and that's awesome. Hi Amelia. The rack was all hand built, green treated 4x4s going down to concrete. They're buried 4 feet in the ground, 4 feet out of the ground, 2x4s centered with big heavy pins so it can float, and then I use this lever system to adjust for summer light and winter light. Winter light, this thing will be standing almost vertical because the sun rises so low in the sky. And that was pretty awesome. And this is 90% of my power comes from the solar. Wind is cool, and it's a fun challenge. It's very unreliable. They happen to be spinning today because the wind is coming from the northeast, and that's about it. In the summertime, that one does good all year long if the wind's blowing. This one is totally blocked in by trees, and in the summertime when the leaves come in, it pretty much doesn't do much unless the wind is coming from the northeast. And right now she's making 50 to 100, 150 watts. I think it peaked 170 for the day, which is cool. It's probably made a half a kilowatt hour by itself. And but this is a 500 watt turbine from Greenie Solutions, Chinese turbine. I swapped out the original blades, and I've got 6 blades set on there. They're the 750 millimeter blades, longest ones that will fit on these hubs. I made a larger tail for it to help keep it in the breeze, because mostly this tree, the wind rolls off of it and turns it out like this, as you can see. That one is pointed correctly. This one, the wind's rolling off and it kicks it out, frills it out. But with the original tail, it basically made almost nothing because it couldn't stay in the wind. That's 1 foot by 2 foot of 16 or 18 gauge steel. I think it's 16 gauge. So it's fairly heavy. And I moved it as far back as I could on the rear stem. So, you know, just to add as much stability as possible, and it's done a good job. We're on a 25-foot pole with 2 sets of 3 guy wires, and just used ratchets actually. Ran my cable right into that for tightening and plumbing, and that worked real good. It keeps the pole straight, keeps it nice and sturdy. It doesn't wobble. It's got to be blowing real hard to get a little wobble in this pole, and it's okay to have a little movement, but you don't want to be losing too much energy. Chickens are all in. I do got a video about that. Solar panel runs to a heater coil inside of there and heats their floor up for the winter months. We'll move on to the big guy. I've done also quite a bit of work on this one. This one has got the 5-blade set. They're 900 millimeter blades. Similar to, if you're familiar with Thermodyne, real similar to the KT style blades. And then I fabbed up that tail also out of 18 gauge steel, and from the back peak to the back peak up and down, it's also 2 foot, and then it's 1.5 feet wide at the peaks. And you can see it's an X tail, and that really helps with stability. The camera doesn't really illustrate how fast it's spinning, but you might be able to hear it whistling. I used a little heavier pole on this. This is 2.5 inch black gas pipe. Also 2 sets of guy wires. This tower is 35 foot tall, and then I also got my weather meter as close as I felt comfortable to the turbine, and just high enough that I could still reach it with a ladder to replace the battery. But for servicing this turbine, it's too heavy to raise and lower. It is a tilting tower. They're both tilting towers. But for servicing this one, I stacked up my scaffolding right along the pole, and that's about the safest way to do it, because this thing is really heavy. It's probably 60-70 pound turbine. There's a massive stator in there and a massive rotor with big magnets on it. It's a heck of a lot heavier than it looks. So at the end of a 35-foot pole, it's really a lot to hoist. So I get the pole up by itself, and then I stack up the scaffolding. I installed the turbine off the scaffolding, and then any service is done off of the scaffolding. Since I put the tail, balanced the blades, I haven't had to do any service, but I will probably do an annual checkup, make sure the seal is holding up and there's not any moisture getting in there, and all the bolts are staying tight, and so on and so on. But this one does really good. That one would do better. It's just in a bad spot. That's really all there is to it. It probably should be on my rooftop or out here in the open. It was my first turbine, my first experience with wind, and I really learned a lot with it. Tell you what, you really figure out how much wind you actually have when you put a turbine in the air. You know, I think there's an old saying, putting a well in the ground doesn't make oil appear. Putting a turbine in the air doesn't make wind appear. Every time I make a modification on these, it seems like I'm waiting 3 weeks for the wind to kick up so I can see if it worked or not. But now that I got her high enough in the air and a nice stable tail on it, it pretty much is always making something, unless it's absolutely stagnant air. But yeah, we're gonna hop in the basement and see what they're doing. Alright, here we are. So there's a main control board, battery bank. We'll start with the battery bank. 10 group 31 deep cells, 5 pairs, 24, and then from each pair we've got equal length positive to negative wires going up to a bus bar. What that does is that completely balances the charge and the load rate going into and out of the batteries, and that wears and uses them all evenly, so you don't have one pair being used more and dying faster, because if one dies faster, then it'll start to act as a load and draw against the rest. So, and from our bus bars, we go straight to the inverter. These are from the charging systems, solar controller, rectifiers, and generator. The inverter is a Sinewave, Japanese company. 3000 continuous, 6000 surge. It actually does 6000 surge. Great inverter. It's about 82% efficient overall, up to 95% efficient at higher loads. Its no load usage is about 30 watts. Really good passive cooling. It's got a massive cooling heat sinks inside with all the MOSFETs on the outside, capacitors and transformer on the inside of that. Cools itself off really well if mounted in the vertical position. For monitoring, we've got on the DC side, that keeps track of power going into the inverter. This one keeps track of power coming out of the inverter. And I get a gauge on efficiency, and I can keep track of that for all the 12 volt DC loads in the house. I've got 24 volt step down to 12 volt. It's a 240 watt, and that goes to this rat's nest that will soon be replaced with these much nicer bus bars, but that runs fans and water pumps and cell phone chargers and lights and various other loads that are just more efficient to use. 12 volt DC. For solar controller, we've got a Peaver MPPT controller. This is their newer Tracer series. This is the 60 amp. Great charge controller. It has a generator stop start function that I didn't put into use yet, but when I get my generator rebuilt with an electric start motor, I am going to program that to be able to be activated off of this. But it's got a great little monitor. So far today we've almost made 5 kilowatt hours. And I reset this about 3 months ago. So 3 months ago, since then, we've made over 1,000 kilowatt hours. So it's doing real good. Not a crazy amount of power still coming in, but like I said, it's almost 5 in the afternoon. So it's getting late evening light. There's the wind setup. We've got our switches. This is basically my high wind speed control. The lines from the little turbine and the large turbine are right here. These switches in the downward position. The power comes straight down through fuses, straight into the rectifiers, and then of course through the meter and to the bus bar, straight to the batteries. That's full power mode. The fan's just kicked on. I got a temperature sensor in the rectifier there, and that keeps the rectifiers from overheating. Right now they're making a little power. Nothing insane. See, that one must have just furled out. Remember how it was swaying out of the wind? It'll eventually catch it. Oh, there it goes. It'll catch it and start making power again. But what this system is capable of doing is, if I put these in the upward position, it then reroutes the three-phase from the turbines through these resistors, and then it comes back across down through the fuses back to the rectifiers. The wind is kind of a little slow to really demonstrate what it does, but put that up. It runs that through. These are 3 200-watt resistors for the big turbine. That's 2/3 of the turbine's capable power. That reroutes it, and see, I'll flip it back up and it'll jump. The power will jump automatically. Wait, 1, 2, 3. See that? Oh, looks like the wind picked up. So it eats up the power inside of these resistors. It heats up the resistors, it slows down, it loads down and slows down the turbine, and instead of a wind break, excuse me, that grounds out the stator, it and heats it up and potentially could melt down your stator. It dissipates the heat off down here safely. So for the little one, 3 100-watt resistors, close to 2/3 of the generator's capacity. And again, that's just a wind speed control to prevent if we get 60-mile-an-hour winds, and these, this one's making 1200 watts and that one's making 800. Batteries are full, the dump load's kicking on, and it just prevents damage. So moving on, we've got our dump load controller. This is what prevents overcharging from either the solar or the wind. As our batteries get full, they get up to 29.2. This activates. This is also from Thermodyne, not Missouri. This one won't start on fire, okay? But yeah, this activates and this starts dumping power through this wire, and that runs over here where we have an electric water heater. Sorry about the light down here, it's an old house. And inside of that, I've got a DC 24-volt DC 600-watt heating element, and this pump here circulates water in between the little tank where the water is heated and the big tank, and it pumps the hottest water out of this one down to the bottom and heats the big tank from the bottom up. This is also a hybrid system. I can flip a switch in here and that draws the water instead. From the top of here, it draws it through the copper coil that runs in my chimney and my wood furnace there. So in the winter time, we heat our water with wood that is already burning, and that works awesome. That works absolutely phenomenal. There's a 20-foot 3/8 inch copper coil in there that gets our water like 140 degrees, and it's just fantastic. In the summertime, I don't need my water to be crazy hot. A warm shower is good enough. So this actually does do a pretty good job. And I put the bypass in there because I don't want it running through that same coil all summer long, because not only can that heat water, it can cool water. It's a radiator. So I hit the bypass, and then it just pulls it straight down instead of from the coil. And that's our dump load. That's what we do with our excess power. And so when the batteries are full and there's still power coming in, this is where it goes. And this warms up water year round. So that is the whole, well, the most of the system. From the inverter, I've got a cut off main fuse, and then I've got 8 gauge running across to the original house panel. I've actually physically disconnected the fuse that goes out to the power lines, and so this just runs everything in the house. It goes straight to it. It goes through the house fuses and to all of the rest of the circuits, the light switches and outlets and so on. And lastly, every system has to have a backup. That's what this rectifier is. That's a 300 amp rectifier. I've got a fan also on that because this one gets hot. And meter for that. Outside, there's a generator box with a 8-horse engine. I got the throttle control in here, and we can go out and take a peek at it and I'll explain it better. So this is a generator, cooling fan on the front and the back side. Keep air moving through it. There's vents where heat can blow out. We got a 212cc Harbor Freight engine. Ran the exhaust out to keep as much heat out of the box as possible. Generator is a Thermodyne dual core permanent magnet alternator. This thing is an absolute powerhouse. I just used a big spring for a belt tensioner and fabbed up some brackets to hold her in place there. Fabbed up this whole frame to mount it all together. For a belt, definitely recommend using the automotive style with ribs. Holds up to the RPMs and the continuous duty a lot better. And then I got automatic temperature control setter for the PMA and the engine. That kicks the fans on, keeps everything from overheating. But yeah, if I throttle this up, this will go over 3,000 watts. I typically charge, if there's no wind, if there's no solar, for 3-4 days. I do have to come fire this thing up and run, you know, a gallon of gas through it, and I'll throttle it up to about 1,600 watts, and I'll just pump amps straight into the battery bank for, I don't know, about 5 hours. I'll get out of a gallon of gas, and that does a damn good job, and it fills me back up and gets me through until the next time we see sun and or wind. And you know, it runs pretty quiet in that box. There's a Stanley tractor muffler on there, and in the future I'll automate that so that I can kick on and off with the solar controller, but for now it works good enough, completely manual operation. But so yeah, that's the system. If you stuck around for the whole video, have a great evening. Bye.